Uh, Today we'll know about Spearman's rank correlation coefficient. I put here Spearman's rank correlation coefficient. Usually this coefficient is denoted with Greek letter rho or RS. Some people use RS. Spearman's rank correlation. This special coefficient which define the dependence or correlation between two random parameters, two ranks of the variable. If we are working with discrete parameters, we use formula Rs equal we use formula Rs equal 1 minus 6 summation over di n times n squared minus n, and here n is a number of or size of the set of estimated parameters, treated parameters, and di is a difference between two ranks of parameters. This analysis is very useful when we are working, for example, two different person, which two different factors or person, for example, which rank some their attitude or stance on something. And to understand how we can use this formula, it's better to go into example. For example, we have a group of students, and we have some statistics about these students, about their grade, the main value of the mean grade, and we know how many times they work on their skills in these subjects which were graded. Grade and time. So we have two parameters, and we want to know, are they correlate or not? For example, 47, 44, 38, 37, 42, 43, 60, 36, for example, 40, 31, and 39. And we know how many times. I don't know how we did it, how we fetched this data, but we know 26, 22, 8 hours, 18 hours, for example, 12, 15, 30, 20, 31, 10 until 11 hours. So students, they have the grades. I filled this one column, and times which they spend on training, I filled the second one column. And what have I do? I have to rank them. To rank, it means that I have to order in descending at least 1, 2, maybe 3. 1, 2, 3, 4 columns here. The first two, rank all the grid, rank all the time, rank all the grid minus rank all the time. I denote like D, difference between ranks, and D squared. What do we have here? What does mean rank? To rank them. Here we have to, we can kind of have to put there. We have to order them descending, starting from the smallest one, and numerate here them. You can replace them, or we can just numerate the position of this number if it is ring according if it is ordered descending. And here we can put the smallest number here, 31, so it is 1. Or next one, 31, 36, 37, 38, 39. What else we have? 40. I don't have 41, but it's okay. 7, 8, 9, 10. So, according our rank system, we have these in front of at the same line of the grid. Its place according the descending order. And the same thing I have to do about times. The smallest one number here, 10, yes. 1, 2, what else? 3, 4, 15, 18, 5, 6, 7, 8, 10. So now we have rank of the time. And after this we can replete the column of the differences between rank. So we have here 10 minus 8, 2, minus 1, 0, 3, 1, minus 1, minus 4, 0, 3. And the last one column is fulfilled with with quadratic form of the previous column. So we have 4, 4, 1, 0, 9, 1, 16, 16, 0, 9. So now we are ready to calculate the ranks correlation coefficient, RS. According to formula, it is 1 minus 1 over 6 summation over the di squared over n times n squared minus 1. Oh, I'm sorry, 6. Okay, I'm sorry, 6 here, times 6 times. And we have 1 minus 6 over n 10 squared minus 1 times 4 plus 4 plus 1 plus 0 plus 9 plus 1 plus 16 plus 16 plus 0 plus 9. Now we can calculate this result. So I calculated it using Excel, and I have result. 0.963. What does it mean? 0.963. It means that there is a very strong correlation between grade of the student and time which they spend on drilling their skills. So you can see that it's very easy to do. So the first one, you have to put some result of your experiment you treated. Then put rank of these results according to descending principle, and rank for the second one number. Calculate differences between ranks, their square, and use this formula. And then I give you the criteria of the Spearman rank coefficient. Spearman's rank coefficient, I put down the formula. There's coefficient and interpretation. Rs equal 1 minus 6 summation of gi squared over n square n minus 1. This coefficient can change between 1 and minus 1, and if its absolute value is less than 0.3, we can say that it is weak correlation. If it is between 0.3 and 0.7, we can say that it is moderate correlation. And if it is between 0.7 and 1, it is a strong correlation. Okay, so we will have a task to calculate a correlation, Spearman correlation, to estimate it, and you can give an interpretation using these 3 criteria. Good luck.